Okay, here's 26 from the mock exam. So if we put infinity in both the numerator and the denominator, we just get infinity over infinity, and that means that we can use L'Hopital's rule. So we're going to take the derivative of the numerator. So the derivative of ln of something is 1 over that something times the derivative of the something. So the derivative of e to the 3x is e to the 3x times 3, and the derivative of x is 1. And the denominator, the derivative of x is just 1. So now we're going to simplify. You might look at this quickly and say, oh, everything is in the numerator, so I'm just going to say that it goes to infinity, but I think we should be a little bit more careful and simplify. So if we do, we get this. Okay, so we're looking at this right now. And now we can use the rule that says, let me just change colors, that if the limit is going to infinity, you look for the highest exponent, which is 3x, and then look at the coefficients. So you'll have 3 and 1. And then your final answer will just be the coefficient. So you get 3 over 1, which is 3, and that was choice C. Okay, here's 27. I drew this beautiful graph for you. So we have to look at 3 different things and decide if they're true or not. So the first thing says that f is continuous on the open interval from a to b. Now this is the derivative of f prime. But if f was not continuous, then there would be a hole in the f prime graph. So it must have been continuous, and therefore number 1 is true. Okay, number 2. F is decreasing from A to B. Oh, and here's A, and here's B. Okay, so if F was decreasing, then F prime would be negative, so below the axes. But you can see that part of it is above the axis, so therefore number 2 is false. Number 3. The graph of f is concave down. Okay, this is f prime, and f prime is decreasing the entire way. So if f prime is decreasing, that means that f double prime will be negative. If f double prime is negative, that means that f is concave down. So therefore number 3 is true. So we're looking for a choice that has 1 and 3, and that would be choice C. Okay, here's number 28. Seems a little crazy, but I don't think it'll be that bad. So we have an isosceles right triangle, which I drew, and the legs are of length s, and the area is 1/2 base times height, but the base and height are each s, so therefore we get the area is 1/2 s squared. Now it's saying that the area is increasing at a rate, so that will be dA over dt at a rate of 12. And it's saying at what rate, so that's our find, at what rate is the hypotenuse increasing, so we're looking for a dH over dt, when s equals radical 32. Okay, and that's pretty much that. Okay, so if the two sides are going to be called s, we can just call the hypotenuse h. And so to get dH over dt, we need some sort of a formula that has h, and thankfully we have the Pythagorean theorem. So s squared plus s squared must equal h squared. So 2s squared equals h squared. So now we're going to take the derivative of each side. So we're going to 4s ds over dt equals 2h dh over dt. Okay, we can divide both sides by 2. And we get that. So we know that the side is going to be radical 32, so I'm going to replace s with radical 32. So we can just at least put in as much as we have. And that will give us that. Okay? Now, the next thing that we're going to need is, or you can look, I mean, even if you don't know at this point what you're, well, actually, you were looking for dH over dt, so you know you have to keep the dH over dt. We don't have h, and we don't have ds over dt. But we do have this over here. So we could say that dA over dt, if we take the derivative of both sides, equals, bring down the 2 and you get 1, just s ds over dt. But dA over dt is 12. And we know that s is radical 32. And therefore, we can find that 12 over radical 32 equals ds over dt. Okay, so I'm going to replace ds over dt with 12 over radical 32, and everything else will stay the same. Okay. All right, so these 32's cancel, and I'm going to get 24 equals h dh over dt. So it would seem at this point that we're kind of stuck and we don't have h, but we do have a way to find h, because we know that at this point s is equal to radical 32. So don't I really have something that looks like this? So now I can do radical 32 squared plus radical 32 squared equals h squared. Well, when you square a square root, you just get what's inside. And therefore, h must be 8. And if you divide both sides by 8, you will get that 3 equals dh over dt, and that was choice B. Okay, we're up to number 29, starting to get exciting, and what's even more exciting is that I am attempting to cook artichokes for the first time, which are probably going to burn because I'm busy making this video. Okay, so which of these functions has exactly one horizontal asymptote and no vertical asymptote? Personally, for me, I like to check vertical asymptotes first. So we will have a vertical asymptote when the denominator equals 0. Okay, so let's look at A. Let me get another color, blue. Okay, so if you look at the denominator here, x squared plus 1 equals 0. X squared equals negative 1. Take the square root of both sides. You can't have the square root of negative 1. Therefore, the denominator would never equal 0, and A is out as a choice. Okay, let's look at B. Whoop. When is x cubed plus 1 equal to 0? When is x cubed equal to negative 1? Take the cube root of both sides, and x equals negative 1. Okay, so that's still in the running. We're going to keep B in the running. Let's look at C. When is e to the x minus 1 equal to 0? When is e to the x equal to 1? Well, if x equals 0, you'll get e to the 0, and that is equal to 1. So C is still in the running. I'm so sorry, I totally screwed that up. It's when do we want no vertical asymptote? So there is a vertical asymptote for C, so C is out, and there's a vertical asymptote for B, so B is out. Let me just go back and put this one back in. Sorry about that. So it was this. Okay, let me just go back in case I totally lost you. So we're supposed to be looking for no vertical asymptote. Well, when we set A equal to 0, there was no solution. Therefore, it has no vertical asymptote. If you look at B, when we set the denominator equal to 0, we got negative 1. Therefore, there's a vertical asymptote at x equals negative 1. But we don't want a vertical asymptote, so B is out, and for the same reason, C is out. Okay, let's look at D. Just trying to get back to my blue color. Okay, so we're going to set the denominator equal to 0. So when is e to the x equal to -1, that is just never going to happen. So therefore, there is no vertical asymptote for D. So therefore, A and D are still in the running. Okay, and now we're going to look at the horizontal asymptote. So for the horizontal asymptote, you want to look to see where is the highest denominator. And if you look at A, which was this, the highest denominator, the highest degree is in the denominator. So the rule says that y equals 0 will be a horizontal asymptote. And we are looking for exactly one horizontal asymptote, so A still looks like a winner. And now let's look at D. Okay, so we're looking for the highest exponent, and here's where you're going to run into a problem, because what if x was a negative number? Then, so let's say it was e to the -2. That's just equal to 1 over e squared. Now we don't have a highest denominator. So it could be, it might not be, we're not sure. So it's saying which one would always have it, and that would definitely be A. So A was the winner. And finally we have number 30. And so we're looking to find the area under this curve from 0 to 2 using a Riemann sum with n subintervals, which means an infinite amount of subintervals. And they are equal to this. They gave you this. So if we have n being an infinite amount of intervals, then that would just be the limit as n goes to infinity. This is tricky. I mean, I don't know if you would come up with this right away. Maybe you would, maybe you wouldn't. I don't know. But if so, this is what your setup would look like. You need to know where is your highest denominator, so we'll multiply out. Okay, and if you expand, you will see on the top you're going to get a 6n squared, and you don't really care what happens after that. On the bottom you have an n squared, so your coefficients are going to be 6 and 1. So that's going to equal 6, and that is choice B, and we are finally done with the non-calculator questions.